Yeah. Okay. Hi everyone. Yeah, thanks for that introduction. So, yeah, it's always weird to do these talks online. Like, yeah, I've been doing a lot of talks before, and it still feels weird. After even doing those, just speaking in front of your computer, and yeah. But yeah. Hold on. But yeah, yeah. Thank you for that introduction. So, yeah, my name is Kurt, and um, yeah, I'm leading the mobile development efforts on our startup called Plentina, and yeah, I'm also a GDE for Kotlin. So yeah, in this session, I'll be talking about a topic that I haven't been shutting up about since the past 2 years, and that's Kotlin Multiplatform. Yeah, but in this session, we're going to be focusing on the mobile side of things. So that's KMM or Kotlin Multiplatform Mobile. So yeah, why do I want to talk about this? So yeah, as engineers, we always want to create apps, right? And when we make apps, that's always code. So yeah, in the context of mobile, yeah, let's say we want to make an Android app, that's code, right? What if we want to expand to another platform? Let's say we want to go and touch on iOS, then that means more code. And yeah, essentially, if you think about these two things, you're building the same thing, just on different platforms. So it's the same logic behind it. It's the same code building the same application, just in different platforms and different languages, but it's essentially the same thing. And which is why a lot of people would just want to share that code, and just have one big chunk of code, and have that for your Android and iOS apps. And so yeah, that's the premise of this talk. And what's KMM? Kotlin Multiplatform Mobile. So essentially, Kotlin Multiplatform Mobile allows us to write the business logic for our Android and iOS applications just once in pure Kotlin. So take note, this is just the business logic. So yeah, we'll dive into that later. But yeah, so Kotlin multi-platform, you can have a single code base for the business logic, using Kotlin. So since you're just sharing the business logic, this allows you to use iOS and Android features without any overhead. So you'd be able to use native stuff. Let's say you can use native tooling on the specific platform. So on iOS, you could use let's say UI kit. You can use the new tool right now, declarative UI for Swift, or Swift UI. And for Android, you can use the existing view system, or something that recently just got released to production, and that's Jetpack Compose, which is another cool, exciting thing in the mobile world right now. So yeah, and aside from that, with KMM, you'd be able to use Kotlin for cross-platform code. And yeah, if you haven't tried Kotlin, it's one of the best languages, at least for me. Once I made the switch, I never went back. As engineers, we have to touch up on different kinds of languages. But yeah, for me, Kotlin is um, um, where I feel really at ease. So yeah, Kotlin. So okay, essentially this is another cross-platform tool, and we already have a lot of cross-platform tools. So why Kotlin multi-platform? So why should we choose it over others like Flutter and React Native? So yeah, in a nutshell, I guess the way I understand it, if code in those platforms, Flutter and React Native, yeah, you're really going to write everything maybe once. You have your big chunk of code, you have your UI and business logic. Your views are going to be coded in React Native, and these are going to get transpiled into Flutter, sorry, into your Android and iOS apps. So yeah, you just have to manage one code base, and that's it. Maybe you have to write a few um, um, platform code, but yeah, mostly you're gonna be touching up on their platform, which is Flutter and React Native, and that's it. Now you have your Android and iOS app. Just build it to the platform you like. Yeah, but with Kotlin multi-platform, it's not the case. So we're just kind of sharing our business logic. So our shared module is going to be, thinner um, than the previous frameworks. So and here, we're going to have our shared KMM module with the business logic. So the logic of our app, and we're still going to have to write our iOS app and our Android app with their platform UI, and just consume that shared logic. So yeah, the thing here is that it's kind of a gray area on what you want to share or what you can share. So you can make this as fat or as thin as you can. So maybe you can like share a lot here. So maybe you can share your use cases, your entities, your networking logic, how to get data from the internet, how to like persist it on your device, and maybe make just make your apps have the views, maybe have their view controllers or their presenters, view model, and or whatever pattern you're trying to use. Or you can make it thinner, make the platform apps um, have more responsibilities. So move the use cases from them, from the KMM module, or I try to put everything in the KMM module. So yeah, just make your Android and iOS apps really dumb, and just present the business logic that we're making in the KMM module. So the KMM module houses everything, and Android and iOS app just um you know it's just like a dumb representation of like your business logic. So okay, yeah. Code sharing. How does this work? So, why can I write Kotlin and deploy it into like an Android and iOS app? So, how does KMM work? So, KMM, so Kotlin rather, can get compiled into three different targets, and that's JVM, JavaScript, and native. So with JVM, yeah, you would be able to like compile your Kotlin code into JVM code, which is bytecode, which is why it's readable and like or interoperable with Java. You can use it in any JVM based framework, and it compiles to JS. So Kotlin going to JavaScript, and native to like your native code, so you can export it to like binaries like Windows executables, so on and so forth. So yeah, so since that's possible, so that means I can like compile Kotlin to JVM, and now I can use it to Android, and I can compile it to native, and now that makes it usable to iOS. And this is the power of Kotlin multi-platform. So it's not just this. So you can also target different other different targets other than mobile. So since it can compile to JS, you can target web. So you can use Kotlin for web. You can use again a JVM for the backend. So if you have like Spring Boot, using Spring Boot, using Ktor for your service, you can use Kotlin. And it's also targeting native. So aside from iOS, you can also target desktop apps. So you have like Mac OS. If you're targeting Windows or Linux desktop apps, that's possible. You can share your Kotlin code across all of those platforms. So yeah, this whole realm of what I'm trying to explain, this is the whole Kotlin multi-platform suite. But yeah, in this session, we're going to be focusing on these two things. And, that's KMM. So KMM is Kotlin Multi-Platform Mobile. So the team at JetBrains saw that, one of the most common use cases for Kotlin Multi-Platform is to share in like mobile apps. So, which is why, they made it a specific use case and made Kotlin Multi-Platform Mobile. And yeah, a specific, I guess, product, geared towards, sharing on mobile. But yeah, essentially it's just Kotlin multi-platform behind the scenes. So yeah. So okay. Yeah, it can compile to JVM to native, which allows us to use it, which allows us to use Kotlin in both of those platforms. But yeah, what's happening behind the scenes is they have this expect actual mechanism where in your Kotlin code, what you're doing is you're saying to Kotlin that hey, I want to expect this from a platform, and in the platform implementations, you're just gonna give them the actual code. So just to try to explain this simpler, let's have this sort of chunk of code. So yeah, I have this expect function saying, hey, I want to expect a platform name. So that tells Kotlin that, hey, I need the platform name implementation on each of the platforms. And I can go ahead and implement that on each of the platforms. So in the actual Android KT file, I can say that, platform name returns Android, but in iOS, it returns iOS. So in the common code, I'm just, trying to call platform name, but, it can know what to call depending on the platform you're running. So if you run this code on Android, it's going to give you Android. If you run this on iOS, it's going to give you iOS. So yeah, it's built on top of this mechanism, but you don't always have to do this. There are a lot of libraries in place. The Kotlin standard library is is multi-platform, so it can already do this. There are a lot of libraries for networking like Ktor for serialization, for datetime. There's SQL Delight for persistence, coroutines for like asynchronous programming. And yeah, there are a lot of tools that are multi-platform nowadays. And yeah, it's easy. It gets easier and easier to make Kotlin multi-platform applications. So yeah, that's just a quick briefer on like what Kotlin multi-platform is. So let's try to see this in action. So yeah, but first let's make sure we're all set up. So yeah, so um, to start, we have to use the KMM plugin. So you can opt not to do so, but yeah, it would be much easier, especially if you're just getting into this. So yeah, set up the KMM plugin. So go to your Android Studio, go to your preferences and plugins. Make sure you have the plugin installed. So if you have this plugin installed, this would allow you to um, have access to the KMM tooling. So when you create a new KMM project, this is going to give you this option to create a KMM application, which would give you a project template on like a new KMM application. And yeah, we're gonna explain what's going to happen there later. So yeah, you have your KMM application, and just like a generic project setup, enter the details, your name, a few more details, and some configurations for iOS. So here you have this iOS framework distribution setting here. Yeah, there are choices over there, and basically just trying to configure your KMM application. Um, so, okay, let's say you use that, you created your KMM application. So, let's try to see on like how this is structured and like how everything's tied together. So, when you create your application, this is going to be the project structure that you're going to get. So, you see, you're going to see that there's an Android app, there's an iOS app folder, and there's a shared folder. So, in the visual manner, here is it. So you have our Android app, we have our iOS app, and it's consuming our shared KMM module. And yeah, so I want to explain how these three things are tied up together. So if you're new to this, it might sound like it's magic, but behind the scenes, it's just simple configurations. So okay, let's start by seeing how the shared KMM module is configured. So when you check the configuration, first things first, it's going to be using this Kotlin Multiplatform plugin. So in the Gradle script, you're gonna see this plugin, and it basically says that okay, this module is a multi-platform module, and since this is a multi-platform module, it now allows me to configure my multi-platform project. So here I'm just saying that hey, in this multi-platform project, I want to target Android, and since we're targeting Android, we also need to set up Android. So we're going to add the Android library plugin and set up all our Android configurations like our SDK versions, the location of our manifest file, and so on and so forth. So okay, now we have a Kotlin multi-platform that's set up for Android. So now let's consume this in our Android app. So it's that simple. Just say Kotlin multi-platform. I want to target Android. Here's the configuration for Android. So now I'm going to consume that in my Android app. So I'm going to go to the Android configuration, and here's the Android Gradle file. So it's an Android application. It's using Kotlin Android, and basically it's just referencing our shared project. So it's just a dependency here that is referencing that shared module we did earlier, and that's it. Now this Android app is consuming our shared code in Kotlin. So yeah, that's that. Now it's configured. So now how do we use this in iOS? So with iOS, it's also the same case. So we're going back to our Kotlin multi-platform file or module earlier, and add some more. So earlier we added Android. Now we just have to add iOS. So there's just a bit of logic here because in iOS you have to think about CPU architectures as well. So if you're using a simulator, you have to use the x64 CPU architecture, and if you're deploying on a device, you have to use ARM. So yeah, there's just some logic over here that's saying that hey, if I'm using a phone, use the right architecture. If not, use again the right architecture. But we're just saying hey, Kotlin multi-platform. I want to target iOS, and this is how you say it. And now that you've told that to Kotlin multi-platform, how are we going to consume this to iOS? So with iOS, there are a lot of package managers, but yeah, one supported package manager is CocoaPods, and it makes life easier when integrating with iOS. So here I'm just saying I want to use CocoaPods, and here are the configurations for CocoaPods, some sample summary homepage, the deployment target, which is 14.1, and this is just going to give us a pod file that we can reference in our iOS project. So this is going to generate this pod file, and if you're not familiar with pod files, it might look cryptic, but it's going to generate this file. And when you look at it first, it might be quite a lot, but yeah, it's actually quite simpler than that. So it's just going to like generate, the pod file based on the configurations that you did. So here's the name. You have some parameters here. Here's the deployment target. There's this Kotlin target variable that says that, if you're in a simulator, use x64. If you're on a phone, use ARM. And it's generating this pod file, but actually behind the scenes, it's just going to add a script that's going to call Gradle. So you're going to see here that there's a lot of code here, but the important thing is it's just calling Gradle, and it's calling the sync framework task in the shared module, which would basically copy your framework over to your Xcode project, so that you'd be able to use Kotlin inside your iOS apps. So okay, yeah, I've configured multi-platform. I told it that I'm going to use iOS. I'm going to target iOS. I'm going to use Cocoa Pods. It generated this pod file. Now I'm just going to reference that in my iOS app, my iOS apps pod file, and yeah, it's just now your iOS app is going to be consuming your shared KMM module. So yeah, it might be a lot, but um yeah, as time goes by, it's going to be easier. So yeah, now that this is your project structure, and it's configured, your iOS app is using Kotlin, your Android's using Kotlin. Now you can just configure your multi-platform setup, and maybe add your dependencies, maybe add a few libraries that you want to use, and yeah, you're all set and you're ready to make your app. So yeah, let's go right away and like see KMM in action. So let's try to make our application. So um yeah, so this is just going to be a simple application. So it's just a jokes app that I've been it's my toy app on Kotlin multi-platform. And yeah, it's just basically a list of jokes, and when you tap on a joke, like the joke comes up, and that's basically it. A simple list, and some interaction in it. But yeah, what's happening behind here is this is using native tooling for Android. This is using native tooling for iOS, and behind the scenes, it's sharing Kotlin code to get the data that they need. So okay, going back to the project structure. So yeah, we have our Android app and iOS app and shared KMM module, right? So yeah, so first things first, we need to figure out what do we need to share, or like what do we want to share. So in this case, I want to share, the logic on like retrieving the data on like the server, or like in the cloud. So, and exposing that to my application. So I want to make my applications as dumb as possible. I want everything to be shared. So yeah, I'm going to be sharing the business logic. I'm going to be sharing the data logic, and yeah, we're going to try to share everything in KMM and see how we can consume those natively. So okay. So yeah, first things first, I want to define my data model. So I have my data class here of a joke, which just defines that I have an ID. So I want to identify each joke, and I have my setup, and I'm going to have a punchline, and that's it. That's my data definition. So the next thing here is that I'm annotating this with with this at serializable annotation, and this is a Kotlin multi-platform library, which is Kotlin serialization, which allows us to serialize to and from JSON, our Kotlin classes. So yeah, it's multi-platform. You can use this in your common code, and you can use this in Android and iOS. So yeah, so I have my data model. It's serializable to JSON, to and from JSON. So okay, now I can use this to like get my objects. So the next thing I'm gonna do is I'm just gonna make a repository that allows me to like communicate with my APIs. So I'm just using this, which is an HTTP client. So again, another Kotlin multi-platform library. So this is from Ktor, and it's very easy to use. I'm just saying, hey, I want this HTTP client. I want to make a GET request, and I'm just gonna call this API. And you can see here that I'm passing this type, which is a list of jokes. And that's because the response I'm going to get from this API is this. So it's a JSON array. Then this is the definition of it. So there's an ID, there's a type which I omitted, and there's a setup, and there's a punchline. And since we annotated that data class earlier, it's just gonna fall right in place over here. And that when we get and call this API, we don't have to do our parsing logic. We're going to get this as a Kotlin object right off the bat. So okay, um, we have that's how easy it is to prepare it for JSON serialization. That's how easy it is to like call um, our network APIs. So now we want to make this asynchronous because this is a network request. So for sure it might take quite a while. So we're going to add suspend function, which is another Kotlin library, which is coroutines. So coroutines allow us to like make asynchronous programming much easier. And yeah, if you're coming from the JavaScript world, so coroutines is kind of like maybe our async await. So yeah, here I'm just saying that this is a suspending function. So yeah, this might take quite a while, and um, yeah, this is how we're going to get our jokes. Oops, sorry about that. Yeah. So okay. Now I can communicate with my API. I can get my jokes. No, now I just have to expose this to my applications. So here I'm just going to create this view model which just uses our repository and exposes an observable stream to our apps. So flow is like an observable stream that we can consume. So um, yeah, our applications are just going to listen to this um, observable, and yeah, we're just gonna float our data here, and yeah, later we're gonna see how we're going to consume this. So yeah, when I create this view model, I have this init block which just says, hey, whenever you start, I want you to launch a coroutine and try to get the jokes and put that in my observable stream. So yeah, that's the code that we did earlier. Since this is an asynchronous code, it's a suspend function. We have to launch it inside the coroutine so that it's going to run in the background. But where did this client scope come from? And so in Kotlin multiplatform, yeah, not everything's built, so you might have to like build a few things. So like let's say for this example, yeah, the coroutine scopes for each platform is going to be different. So like let's say for example here, I'm going to create an expect class which is for my view model, and yeah, I have to say that in each platform the coroutine scope is going to be different, and I have to clear them in a different manner as well. So in Android, if you're familiar, we have our lifecycle view model in Android architecture components. So yeah, you can use that and extend the functions that are available, and um, the tools that we're available with. So I can use the view model class, and I can use the view model scope extension, and I can just like call the super class when clearing those, and the life cycle is already handled. And yeah, so this is going to be the behavior on Android, but on iOS I don't have that tool, so I'm going to create my own implementation of scoping the coroutines. So yeah, you don't have to understand bit of this code. What I'm saying is that we're just defining different implementations on the platforms. So but yeah, but by doing this, we can call this and use this um, in our Kotlin code. So going back to our Kotlin code, so what we just need to do is, add this base view model here. And when we use this on Android, it's going to get the right implementation. But when we use this on iOS, it's going to give us, again, the right implementation for iOS. So so yeah, so now that's that. So we created, the whole suite of like, we have our data model, we have our repository trying to communicate with the server that's also parsing it to from JSON to our object, and we have the view model who's handling this and exposing this to our views. So yeah, this is fairly simple, and it's just a few code. So but this is our whole KMM module, and this is now already consumable for Android and iOS. So now let's try to consume this in our um, Android app. So okay, here's my Android app. So and here yeah, I got way too excited in Compose, so I tried to use Compose in this project. So yeah, here I'm just saying that I have a composable, I have a joke item. It needs to get a joke model, and with that joke model, I'm just creating this composable that generates the text. So I'm going to display the setup, and then I have this state being handled over here that if the punchline is visible, then show the punchline. If not, then don't show it. And whenever I click on this object, just change the modify just modify the state, and it would change the visibility of that composable. So okay, that's my item. And here's the next thing, which is, to consume this. So now we're in the Android world, and you can see that, I'm consuming the view model that we just made from the shared module. So, as we configured earlier, this is accessible in the Android app. So yeah, I can create my view model over here. And yeah, I'm collecting the jokes. And here I'm just passing it into another composable saying, hey, I want a column. And here's the list of jokes from my view model. Please generate a joke item on each of those jokes. And that's it. Now I'm going to have this application, just with, a, a few lines of code. Now I have this application. So I made the KMM module, and then I added a few Jetpack Compose code. And now I have this list, and, I can tap on it, and I can, see the punchline of that joke. So, okay, yeah, now we have our Android app, but that's not the point of this, right? The point is to share this in iOS. So let's go ahead and, consume this shared module in iOS. So one thing in iOS is that, we can't use coroutines because we're not using Kotlin and Android. So, or rather in iOS. So we're using Swift. So one extra step we have to make is, we have to have this workaround, which is from the JetBrains team. So they did this in their Kotlin conference app. Um, but yeah, what we're doing here is we have to expose a function to iOS so that they can consume our flow objects and get the details from there. So yeah, so we made this common flow class. We're exposing a watch function, which basically just listens to the flow and propagates it through a lambda. And so yeah, with this now we can use this in iOS. So you can use this in iOS and just some helper function to like let us convert our normal flows to a common flow. So now we can go back to our jokes view model, and here we have our jokes view model. So we just converted this from a flow to a common flow, and we use the helper function as common flow to make this consumable to iOS. So yeah, just a few configurations for iOS. But now, since we did this, we can dive in and consume this in Swift. So now I'm going to the iOS world and do something that's native to iOS, which is go with Swift. So here I'm just going to consume the view model. I have this observable object. I'm going to publish it. So these are iOS constructs. Um, and yeah, again, like earlier in Android, I'm just consuming the shared module, which is jokes view model. So I'm not creating everything. I'm just reusing what I already did in Kotlin. And yeah, I'm using this watch function that we just added so that we can consume this. So I have this on start function. I'm trying to watch the jokes from the flow. And I'm just assigning this to the array that we're trying to publish in this object. So okay, now we have this. Let's create our UI. So just like earlier in the Kotlin world, so yeah, I have a joke item. We're going to pass in a joke model over here, and I'm going to display the setup. If the punchline is visible, then let's display the punchline. And there's some state that's being tracked over here. When we tap on it, we change the state, and yeah, now we create the whole list. So we're going to use our view model and make our list for each of those jokes. Let's make a joke item. And yeah, um, we're just going to use basically the Kotlin Multiplatform module. And yeah, again, with the few lines of code on iOS, now we have our iOS app, which is, already running. So yeah, with Kotlin multi-platform, you're sharing the business logic, um, but yeah, you're creating your applications, with native tooling, and it's really great. It's really great. So yeah, this is just really brief like demo on like KMM like in action, right? Like there's a lot more to this for sure. Like I've been using this for the past 2 years, and yeah, it's come from a long way. So before it was really quite complex, but yeah, now it's easier and easier to get into it, and it's easier to make more native apps. So but yeah, Kotlin multi-platform. So how is this again? Like earlier, the question earlier, right? So how is this different from using cross-platform frameworks like Flutter, like React Native? So they're still creating apps, right? So yeah, why this? And so yeah, which leads me to my next section is like deciding to use KMM. So should you use it or not? So yeah, this actually would depend on you and like on your use cases. So whenever I try to talk about Kotlin multi-platform, I always try to borrow from TouchLab, which is one of the companies that's kind of leading Kotlin multi-platform. And yeah, they made this rubric for themselves that led them to their decision to adopt Kotlin multi-platform on their projects. So So with them, they decided that the UI layer wins with Kotlin multi-platform, which is kind of weird because we're going to write a lot more UI code with Kotlin multi-platform as compared to Flutter and React Native. But yeah, they decided that Kotlin would win because since in Kotlin multi-platform you're going to write your code in UI, you have your you have first class citizenship with your platform. So they thought that it's really powerful, and they decided that in this section or category, Kotlin multi-platform would win. So they try to decide on a few more things like business logic. It's better to write it in Kotlin. Developer efficiency. Your developers are going to use Android Studio and Xcode, which is native tooling in the platforms. As compared to React Native and Flutter, if you have native developers, they're going to have to transition to JavaScript or TypeScript. They're going to have to transition to Dart. But again, this depends on the use case. What if you have a lot of like JavaScript engineers? Maybe it's better to like go to React Native. Um, and but for them, yeah, they have native engineers, I guess. So which or like maybe they just thought that it's much better to like work in Android Studio or Xcode. Effort to output ratio. Yeah, you're going to put a lot more effort in Kotlin multi-platform, but you're gonna get a lot more on your output. So yeah, not to say that the other platforms are not of quality, but it's just that you're gonna get a lot more quality with KMP. But then again, you have to put a lot of effort to it. Code sharing potential here, Flutter wins because like you can just write it once and deploy it to different platforms. So with KMP, you're going to do a lot more work. So yeah, there's lesser code sharing potential. But yeah, they decided that for the application quality overall, they're going to go with KMP because it's native, and yeah, it's native to the platform. So yeah, so I'm not saying these are the only things that we're going to be thinking about in deciding to use KMM, but TouchLab made their own rubric. So we have to make our own rubric as well. So as developers, using KMM has to be a conscious decision. You have to think about your project. Is this going to be used in is this going to be a long-term project? Do you have the resources to do so? Do you know Android and iOS? um, do you have developers that can use this, that can do this? What are your time constraints? Etc. and etc. So you have to be able to figure out what the right platform for you is. So maybe if you're just a solo developer, you don't know anything about Android and iOS, maybe it's more prudent to use Flutter in that case, especially if you're like trying to reach a deadline. But if you're a native developer and you're already using Kotlin, maybe it's better to like invest a bit in like maybe try to look at the iOS side. And you already have your code built in Kotlin, so that's good. Convert that to KMP, and then expose that to iOS. So front end development is kind of the same. It's just in different languages, but essentially it's just the same. So you just have to learn how to make it in a new platform. So yeah, again, it has to be a conscious decision. You need to like make the decision for yourself. But yeah, there are a lot of things in play, and you have to be thinking about that. But yeah, this is just a sample of Touch Labs rubric, and yeah, I always like the rubric, and yeah, I always try to like present this whenever I talk about Kotlin multi-platform, and try to advocate this to people. So okay, let's say you decided to like use Kotlin multi-platform. So how is it going to be now in your team? So um, so KMM in your team. So yeah, usually when you're on a mobile project, you have a team. It's you have your iOS and Android teams separate from each other, right? So you have your task. The Android team implements it on their own. The iOS team implements it on their own. But now this is going to disrupt your process because now you have your shared code base, and now the other platform has to be thinking about the other platform because you're sharing code that would affect both of your platforms, right? So yeah, a fairly simple process, as with anything, is planning. Just plan what you do, develop it, and make sure it's tested. But yeah, some of the key points, I guess, when once you try to have this setup is, when you're planning your shared module, figure out what to share. um, what can you share actually, between Android and iOS. So you have to have a clear decision on like, what do you think is shareable on each of the platforms, and figure out who does what. Is this going to be done by the Android team, by the iOS team? And yeah, now you know what to share. How are you going to consume that API on each of the platforms? So these are the decisions you have to make when you're planning. So it's just going to maybe act as like another backend. So if you've been working with backend teams, you're gonna have to like do that sort of planning, right? Okay, how do I call your backend? What response am I going to get? What request am I going to give you? So it's essentially the same thing, but you're gonna just scope it in the mobile world, and just figure out APIs, figure out um, what you need on each platform, and yeah, just basically try to figure out everything that you're going to share. So okay, now you plan, you're making it. So yeah, once you're developing, you have to make sure that you follow the contracts that you have from planning. So yeah, like I said, your change is going to affect both teams, right? So you can't just deviate from what you have planned, because both teams have expectations, and one small change can change everything from the other team. So you have to be sure that you're going to be follow the contracts from planning. So if ever there are issues or concerns, you have to raise it as soon as you can. So yeah, we can't plan everything right off the bat, and sometimes it's just a lot. So sometimes we miss a few things, like we're people, and we miss a few things, we make mistakes, right? So but yeah, once you see those issues, raise those concerns as soon as you can, so that you can maybe try to talk about it again, and like have another plan, and find something that would um fit for the two teams, and that would work for the two teams. So yeah, this is to prevent each team from like getting their expectations um or like you set their expectations, and you're going to give a different result. So yeah, that's going to like impact the output of the other team. So yeah, make sure you're aligned. If there are issues, align as soon as you can. And yeah, now that you're done developing, do some testing. So since you're sharing a module, you need to ensure that there's feature parity. So you need to ensure that what's working in Android is also the same in iOS. So it should behave the same way since you're sharing code. So yeah, if there's a bug, figure out that if is it from the shared, or if it's from the shared code, is it from the platform code? So most probably, if the bug is in both platforms, maybe it's in the shared module. But yeah, you have to figure out a way to know where you're going to debug, or like where you're going to fix this. And yeah, one thing that would be helpful for each teams is to perform a code review on the other team. So yeah, let's say the Android team reviews the iOS team reviews the Android team. So by doing those and peeking into each other's methods, and like how do they present this on iOS, how are they doing this on Android, you would get more insight on, or more perspective on how to do it on their platform. And this is going to be an iterative process, and as you go through this, you're going to be learning a lot. So you're going to learn through their code, you're going to learn through what they're thinking about, um, um, and yeah, just do this iteratively, and just learn from each other. And as you do that, you're gonna have more and more ease in like trying to figure out your contracts, and like what you're going to share in each on the platforms. So of course, as you get to know them, when you're planning, okay, since I'm from the Android world, I've tried to peek onto the iOS world. Now I know how it is to like work on iOS. So when I make the KMM module, we need to make this in this certain manner, so that the iOS team can consume this. So you would have that connection with them, and you would know um, how to make things better for both of your teams. So yeah, this is just a simple process. But yeah, so KMM, some approaches, I guess, with KMM. So yeah, there are also different approaches with, I guess, team composition. So since you have your both native Android and iOS teams, so I guess the common path to go here is have your Android team manage the shared code. So since they're already in the Kotlin world, um, yeah, it's a no-brainer. Let them make the shared code, and it's in Kotlin. They can definitely do that. So yeah, this is good, but it kind of makes the iOS at the mercy of the Android team. So the iOS team is just going to be waiting for the Kotlin multi-platform module, and it's kind of unfair to them. So what if the Android team does something that doesn't work for the iOS team? Then there's a problem over there. So I guess the best way here is have everyone on board on the shared code, and have both the Android and iOS teams work on the shared code. So, but the problem here is now is then there's going to be bias, because like the iOS team is like working in Swift, working in their native tooling, UI kit, Swift UI, whatever tools they're working with. And then the Android team is again, still in their own happy world. They're using Kotlin, they're using something that's really good for them. So the iOS team has to like adjust to the Android team, and there might be some sort of friction over there. So yeah, ideally this would be the setup, right? But you have to figure out how to onboard your iOS team and like contribute there. So yeah, maybe you can let the Android team learn more on iOS as well, touch up on that, so that it's going to be a two-way street. The iOS team touches up on Kotlin, the Android team tries to touch up on iOS, so both can understand each of it's a two-way street, so like both can understand each and every one. So yeah, and so maybe if you're bigger, maybe you can have a dedicated Kotlin multi-platform team. You have your Android and iOS teams just focusing on your front ends, and you have a Kotlin multi-platform team creating your multi-platform code. Um, in this case, it's like you're gonna have another backend team, I guess. So you have a backend your multi-platform team for your mobile apps, and for me, this is kind of overkill, especially if you're just a small team. Yeah, maybe you can have this if like you're like a big team and like you have a lot of features to build, and so yeah, it depends on I guess the state and the composition of your teams. But yeah, the ideal one is have everyone on board Kotlin multi-platform and have everyone contributing to your code. So yeah, okay. Yeah, this is Kotlin multi-platform. You decided on it. This is what's going to happen. This is how we're going to do this. So how do I introduce this to my team? So um sorry. So yeah, so how do I introduce this to my team? So I want KMM, I want to push KMM, but yeah, how do I get everyone on board? So yeah, I guess first, start with empathy. So you have to understand that that you were working with people, and yeah, and any new technology is kind of a risk, right? So like there might be some sort of resistance to working here. Like let's say for example, the iOS team. I'm working on Swift now. I have to move to Kotlin. So yeah, you're making some people change from what they're comfortable with. So the Android team, they have to give up some tooling as well. So one of the things that I really miss is like working with Dagger. Like there are new tools like Hilt, and that makes dependency injection easier, and the Room database, a lot of like native tooling that you have to give up, and you have to understand that these are people, and they have their own experiences and biases, and you can't just force that, hey, I want KMM, now we have to use this. So you have to understand that um, you know um, there's going to be some resistance to this, so you have to be ready to like introduce this to them. So yeah, start with empathy, understand them, understand what just understand your team, and yeah, so you can go ahead and explain how KMM works. So explain it. Kotlin multi-platform. Yeah, you can compile to three things. You can just write it once, and yeah, Kotlin multi-platform. Just explain it to them and like let them know that this. You've done your research, and that your decision here isn't just um based on like what you want, but this is based on like the on a lot of things. So, and to do that, you can show the value. So this is how KMM works. When we do this, this is what we're going to get. So we're writing each code separately, but with Kotlin multi-platform, we can share a chunk of our code and still be a native. So yeah, show them that value. Let them understand that this is for the best of your project. Assuming that you already decided that this is going to be the best for your project. So let them know those and let them understand that, and yeah, try to offer proof. So there are a lot of case studies already online. So KMM is still in alpha, but there are companies that are already using this in production. So if you're familiar with Cash App in US, so they use Kotlin multi-platform extensively. Netflix also uses Kotlin multi-platform in one of their I think it was a studio app, I forgot, but yeah, they use it in one of their apps, and yeah, they use Kotlin multi-platform. There's VMware, there's Kareem, there's TouchLab company, and I think there's also Philips. Yeah. So Kotlin multi-platform is in alpha, but there are a lot of case studies on like how KMM is being used in like different applications, and yeah, it's working well. And so yeah, offer them the proof, let them show them the value, and tell them that hey, a lot of people are doing this. This is a really good thing, and yeah. you can only show so much. You can, yeah, you've told them how it works. You've showed them the, the value that it can give. You've offered some proof. So yeah, prepare for questions. So you can't you can't yeah, you've given them the information that they can, but yeah, for sure, like I said, there's going to be some sort of resistance, right? Or yeah, or not even resistance, maybe like they just want to know more about it. Yeah, be prepared for those questions. So again, going back to what I said earlier, that you can't just impose that you want this here. So they're gonna want to understand why we're moving here. They're gonna want to understand what this is. So prepare for a lot of questions. And yeah, once you're making it, be supportive. So it's going to be a process. It's not going to be a quick and you know easy job to do. So be supportive of, like, you're gonna have like maybe ups and downs when you're going here. There's gonna be some difficulties when you move here. So be supportive of your team. And yeah, um yeah, so these are just some, some tips and maybe things you can do if you want to introduce KMM to your team. But yeah, for sure there are a lot more and better ways to do this. There's a link over here. But so yeah, these are also guidelines from the JetBrains teams, or the JetBrains team, or the Kotlin team themselves. So but yeah, Kotlin multi-platform, to me, it's one of the things that I'm really excited to be working with. And yeah, at Scotland Multi-Platform. So yeah, thank you for listening to me geeking out about Kotlin Multi-Platform, and I hope you learned something. So yeah, I guess that ends my session, and yeah, we can proceed to our Q&A.
Hiker, we'll just
Hey,
have some
hello.
for you from our viewers.
Okay.
Hmm. First question. Is it good to insert Java code to Kotlin?
Java code to Kotlin. Um, Yeah, not sure what you mean by inserting Java code to Kotlin, because like yeah, one thing for sure is like Kotlin is interoperable to Java, so you can use um you can use your Kotlin code in Java, and you can use Java code in Kotlin. So yeah, if you're going to like make them, you're going to be making them in separate projects. You're going to be having a Java code, Java project. You're going to have a Kotlin project, and import them to each other. But yeah, I'm not sure what you mean by inserting Java code to Kotlin. But you can definitely use Java code in Kotlin, but in a Kotlin manner. Um, um, yeah, not sure if it's a matter of like, is it good or not. Yeah, there are definitely a lot of Java libraries, still not converted to Kotlin. You can definitely use those in Kotlin. That's no problem. And yeah, yeah.
Okay, our next question. What will happen if I connect KMM to KTOR?
Yeah. So yeah, what will happen if you connect KMM to Ktor? So yeah, so like I said earlier, right? So Kotlin multi-platform works because, like, it's under the realm of like Kotlin multi-platform, which allows us to share, in different platforms through um the three compilation targets, which is JVM, JavaScript, and native. So it allows you to like connect it to your backend, to your desktop, to the mobile, and to the web. But yeah, KMM falls or like just touches up on mobile, so Android or um, iOS. So once you connect it to Ktor, you're moving out of the mobile stack, and it's going to make this KMP, so your Kotlin multi platform project. And yeah, now you're going to be sharing code between like your front end clients, your mobile clients, and your backend. So yeah, you can connect this, but yeah, you have to figure out what to share between mobile and backend. So I haven't done a project where I've shared between the mobile and the backend, because like when I always try to scope it out, the best I can share is I guess data models. So it's going to have different business logic for each. So the mobile app is mainly focused on presenting, how to present this to the user as a view, fetching data from the server, and the server has different kinds of logic as well. So I didn't see much of a way to connect those except from the data models, which I think is really thin, and I think at least for me, I decided that it's not worth the effort. So yeah, I just stuck to using KMM specifically for mobile, but you can definitely do so. Maybe you can find the use case that would work for you. Maybe you can share your code between mobile and the backend, and yeah, you can definitely share those. Not sure what would happen, but yeah, yeah, you'd be sharing code, but yeah, not at least in my case, I haven't been able to share a lot of code and connecting those. But yeah.
Okay. Do we have another question? Okay.
Mm-hmm.
How to debug KMM app on runtime, like debugging the business logic on both platforms?
Yeah. Yeah, that's a good question. So, yeah, so when you're on the Android world, yeah, it's easy to debug because, like, yeah, you're native, right? You're on your Android world, so yeah, you can just use native tooling. So if you're an Android Studio, you can just use the debugger, and yeah, you can add breakpoints. You can use basically how you're debugging on Android. It's going to work well on what do you call this? It's going to work well on Android. But yeah, if you're on the iOS world, this is one of the I guess disadvantages if you're using this. There's not much tooling yet, I guess, for iOS. So there are some libraries or some tools that would help us to debug in iOS. But yeah, when you're having problems in KMM, at least in my experience, that it's always hard. Sometimes it's going to give you a cryptic error, and you're running from Xcode, and it doesn't have that deep integration with Kotlin as much as Android Studio does. So um yeah, you can definitely debug it. You can also perform some testing on it. You can um um, it's definitely doable, but yeah, it's definitely a much harder route on iOS. I'm not sure what the state of the tooling is right now, but yeah, from my experience, it's definitely going to be harder on iOS as compared to Android. But yeah, both are doable, and yeah,
Okay, our next question. How's my app performance when using KMM?
yeah, performance. So yeah, since you're using native, right? So you're going to have the same performance as a native app. So yeah, yeah, that's it. You're going to have the same performance, when you're using yeah, because like you're developing it in like your native tooling, right? So yeah, it's going to have that same quality. But then again, this is kind of dependent. Are you writing performant code or not?
Yeah.
Of course, if you're writing non-performant code, that's definitely going to be um a blocker to performance, right? But yeah, generally, if you're making it, at least in my case, yeah, I never had issues with performance, and yeah, so far so good. So yeah, but if you want to make it performant, for sure, there are ways to make it performant. There are strategies. Most likely, it's going to be in the UI layer. I guess one example is for lists. Yeah, maybe you're generating your lists at once rather than generating the things you need. So yeah, at least on the mobile side, yeah, the performance is okay, and like everything is dependent on the UI layer on my case. But the shared module to me, yeah, they're pretty performant in my use cases, and I haven't seen a case that it didn't work for me. But yeah, that's what worked for me. That's what happened to me. So you might have a
Mhm.
different case where you're trying to build another thing that where you need performance and you need to do a lot more tweaking. But yeah, on the general use case, like with mine, it's still performant. It's still the same as native.
Okay. Um, oh, do we have another question? For
Hmm.
existing projects, what are the common issues when converting to multiple platform using KMM?
Yeah. So yeah, this is kind of one of, I guess, the hard parts. So um, um, yeah, let's try to start with the people. So yeah, I guess one is first, yeah, the resistance that people are people, change is always hard for people, right? So yeah,
Yeah.
let's say you're on your Android team, and like, yeah, like I said earlier, I'm using Dagger before. I'm using Room, a lot of like libraries from the Android team, and I had to give up those kinds of things. And yeah, I already feel comfortable with using them, and now I have to give up them. I have to give them up and use
Mm-hmm.
another tool just to support Kotlin multi-platform. So I guess that's one issue. You have to figure out that your team is going to have some sort of resistance to it. They're going to want to stick to their to what they're comfortable with, and yeah, that's one thing. So once you get past that and everyone's on board, I guess there are a lot more, but yeah, I'm trying to make this
Mm.
brief. So once you get past that, you're going to have to learn Kotlin multi-platform. So a lot of my knowledge on Kotlin multi-platform is by trying it over the past 2 years and like going through a lot of um, U-track issues, going through Kotlin Slack, going through Stack Overflow. So yeah, like I said, it's an alpha, right? So I think
Mm.
it just got to alpha last year, or was it? Yeah. But yeah, I've been like an early adopter of this, and it's really really hard before, and like there's less documentation. Sometimes the documentation doesn't help, and you have to like use your own. You have to like try to find workarounds. You have to like file issues. Talk to some of the Kotlin team. So um, yeah, since it's still in alpha. Even though like a few companies made it work for them, you might run into issues and you might run into some difficulties with doing it. So it's not that ergonomic yet. It's quite ergonomic in some sense, but you're going to have some issues in setting up your Kotlin multi-platform project. But yeah, like I've shown earlier, it's easy to consume multi-platform libraries right now. For me, the biggest thing is trying to set it up and that trying to make sure that it's configured for iOS, it's configured for Android. But once you get past that setup, I think it's going to be smooth sailing as long as you have systems in place on like how to make your on like what you're going to share or what you're going to do. But yeah, to me, it's just those,
Mm.
the resistance between your team and I guess setting up and like making sure everything's running smoothly. So yeah, but after those, I think it's pretty much easy. Again, like I said earlier, in Android and iOS apps, you're essentially writing the same logic just in a different manner. So yeah, with Kotlin multi-platform, again, it's the same logic just in a different manner. So yeah, once you get that up and running, um, you're going to have a good KMM project.
Okay. So I think this is our last question. Is there disadvantages from KMM?
Mm-hmm. Yeah, so disadvantages in KMM. So yeah, I guess yeah, so like I said earlier, like this is an alpha, right? So yeah, I guess that's one disadvantage that you can say. So yeah, there's what do you call this? So it depends, I guess, on your appetite. Are you okay to like use an alpha um
Mhm.
tool? um yeah, it's an alpha tool, but again, like some people are using it already in production, right? So yeah, there's
Mm.
some sort of confidence that that can give you, but it's going to be much harder, I guess, to like sell this to like your to upper management and like, hey, we're gonna use KMM, and then like they're gonna see, oh, this is an alpha build, maybe we're not confident
Mhm.
here on this, or on this. Yeah, so there's that. Since it's an alpha, you have to also think of stability. So things are always changing. It's rapidly changing. It has changed a lot from like the past 2 years, but it got easier. It changed for the better, at least for me.
Mhm.
So yeah, you're going to have to be comfortable with a lot of changes, breaking changes, along as Kotlin updates, and Kotlin's updating really fast right now. So it's already at 1.5.2,
Oh.
and 1.5.3 is already nearing, and there's a lot of things that's really changing rapidly, so you have to be comfortable with that.
Mhm.
Next, yeah, like I said earlier, one disadvantage is developer experience, especially for
Yeah.
the iOS side. So yeah, the iOS team is going to be having to like is going to be greatly impacted by this, and they're going to have to be giving up a lot of things. So yeah, for them it's a big advantage. So developer experience for your team. So you need to be aware of those. But yeah, like I said earlier, once you get things set up and running, it's just like you're building a native app. And just you're just sharing like a big chunk of like your code. But yeah, it still runs natively. So yeah, I guess those are some of the disadvantages at the top of my head, but yeah,
Uh-huh.
um, yeah, there probably is more, but yeah, at the top of my head, those are the things I can think of.
Okay, I think that is all. Thank you, Mr. Kurt, for joining us today. It's
Thank you for
truly a
having me.
pleasure for us. Yeah, thank you.
Thank you.